Hi everybody, welcome to our first video. This video is going to be Unit 1, which is on functions, and this video is covering Lesson 1.1, which is on relations and functions. It's kind of an introduction to functions. This Lesson 1.1 got a little bit long on the video, and so I broke it up into two videos. So this is Lesson 1.1a on relations and functions. Remember, as you are watching the video, make sure you're taking notes. You have your pencil in your hand, you have your notes in front of you, and you are following along and taking notes along the way. And let's go ahead and get started. Okay, let's get started on our first lesson. Before we start on this, actually, I want you to turn over your packet to the back page, and I'm going to turn to the back page also. So I want you to notice on the back page that there is a place for the date, and notice it says subject to change. Because this year is so different, I have set up some tentative dates, and I can't promise you we're going to stick to those, but I think we can stick to most of them. Anyway, if you want to write this stuff down, you can. So if you need to pause the video and write this down, go ahead and do so. But let me explain what it is. Basically, what we will do, we will follow a pattern of your homework would be to watch a video. And you always can do that by yourself. And that's why I assign it as homework. It's an easy thing to do on your own. So you would do homework on your own. And then when we come to class the next day, then we work on the assignment. And my goal is that in WebEx, we would be able to do small groups in WebEx. And so you would work on that assignment together with your partners. So that's the rhythm that we will follow for this class. So the 1-1 assignment, the lesson, the video would be homework on Friday, and the assignment would be Monday, Tuesday in class. Then 1.2, video is on Monday, Tuesday, assignment is Wednesday, Thursday. End behavior is video on Wednesday, Thursday, assignment on Friday. Then the bottom half I have not set dates for yet because I want to see, can we even stick to that schedule? Are we going too slow, too fast, what have you? But I do plan on having a quiz on Monday, Tuesday, and that quiz will cover lessons 1.1 to 1.3. Let me write that down. Okay, so again, quiz Monday, Tuesday, September 21st, 22nd, covering lessons 1.1 to 1.3. Again, if you need to pause and write this stuff down, I would recommend doing that. If you need to rewind to the top part of the page, you can do that too. And now we're going to turn over to the front page and get started on lesson 1.1. Okay, so here we are in lesson 1.1. Here's the deal. I mentioned this before, but I have these set up in Cornell style. That's how we plan to take notes. I'm asking you to write down basically anything I write down or type in, you should also write down. So today we're talking about functions. A relation sometimes is a function. A function is a subset of relations. So relations are just any two ordered pairs, just x, y. That would be a relation. A function is a little bit more specific. It has only one output for every input, so only one y for every x. And, well, here we go. In other words, every x has only one y. Also, some of you might have learned the vertical line test. A function passes the vertical line test. If it doesn't pass the vertical line test, it is not a function. So some more terminology. When we talk about functions, we talk about domain and range. And in different settings, we call the domain and the range different names. So often, the domain is your x value, and it is your input or your independent variable. And the range is the output or the dependent variable. So all of those words, like all those words on the top would go with the x value, all of the words on the bottom would go with your y value or f of x. So remember that y and f of x are the same thing. All right, so now that we've talked about that, let's talk about what is a function and what is not a function. Take a minute to look at these two tables. One of them is a function, one of them is not a function. Can you discern which one is which? All right, the first table is a function. How do I know it's a function? Well, for every x, every input has only one output. So it's just, you can see, there's nothing that repeats in the x column. Now, there is this 6 that is repeating, but 2 gives us a 6, and also 3 gives us a 6. That's okay. It's okay if it repeats in the y column as long as it does not repeat in the x column. Then it is asking, part B asks, if it is a function, state the domain and range. Here the domain is all of my x numbers. That's 0, 1, 2, 3. And then the range is all of my y numbers, which is 4, 5, and 6. And that's our notation. Typically we use D to stand for domain and R to stand for range. My braces aren't totally pretty right here. I tried to make them a little bit better over here. They're the braces that look like that. I just had to kind of squeeze them in that space. Okay, so table A does represent a function because every x has only one y. If we look at function B, or not function B, right? It is not a function because every x does not have one y. Here you have x going to 1 or 0. You also have a 1 going to 1. Well, that's not a function. 2 goes to 2, and 2 also goes to 3. So that is not a function. Basically, some of the x's have more than one output or more than one y. So I typed that in there. Some x's have more than one y. That makes it not a function. And you've probably done some of those mapping diagrams where like on this one, for instance, that 6 and 6 that repeat with the 2 and the 3, you draw those lines. And so maybe another way to say it would be a 2 here and a 3 here, and they both go to 6. Whereas on this one, there's a 1 that goes with a 0, and there's also one that goes with a 1. This setup is a function. This setup is not a function. Okay, maybe for me, the vertical line test is easier. I guess I'm more of a visual person and I like to see things. So do you remember the vertical line test? Take a look at C and D and decide which one passes the vertical line test. So you should notice that C does pass the vertical line test. The vertical line test basically says if you take a vertical line, and I'm just going to take one of those, and if I take that vertical line and I drag it across the function, the question is there anywhere that it hits more than once as I'm going? No, there's not. It is always just hitting it just once. So this one is a function because it passes the vertical line test. And sometimes I just abbreviate that VLT for vertical line test. Now if we look at this next one, if we do the vertical line test, look, it's hitting it more than one time. That does not pass the vertical line test, so that is not a function. Let's go on to the next section. All right, a big thing with functions is there are 3 ways to represent a function. You can make a table, a graph, or an equation, and that's what we have here. We have an equation, a table, and a graph. Each of those is going to represent a function. And so if we look at equation, here's our equation. That is a line, right? You guys have learned linear equations before, and this is in slope-intercept form, y equals mx plus b. So if I graph this, I know how to graph that from y equals mx plus b. That is a function. Let's take a second to fill in the table of how that would be a function. So if we take a -2 and we plug in a -2 there, what would we get as an answer? Well, if we plug in a -2, it's going to give me -4 plus 3, that's -1. Okay, how about if we plug in a -1, what are you going to get? You get a +1, and then a 3, and then a 5, and then a 7. A linear function, which is what this is, should go up by the same amount every time. And it does. If you see it's going up by 2 every time. Where'd that 2 every time? Where'd that 2 come from? Well, it came from this 2, the slope. Okay, so we have an equation, that is a line. We have a table. Let's look at, are there anything repeating, especially y's? No, there aren't. If we graph this, we could graph each of these points. Okay, if I graph the points, I get it like this. I took those from the table, but you also should remember how to graph this. You start at 3 on the y-intercept, you go up 2 over 1, up 2 over 1. I'm going to go ahead and connect those with a line. Okay, so the graph is this. That is a function. Here's my table. It is a function. And here's my equation. It is a function. So that's something we need to know about functions. Now, before I put that line on there, it was just a couple of dots, right? And then I connected it with a line. Why did I connect it? Well, I connected it because it was an equation. In other words, I'm going to take that line off real quick. If I take that line off, I still have my points. But the reason I connected them is that I could put in a 0.5 into this equation. I could put in a 0.25 into this equation. So I put that line there because Not only the integers, the whole numbers, but also the little fractions along the way, they all would work as well. There's a special name for that. That's called continuous. A continuous function is one where the points are connected. There are no breaks. It also means the domain, the x's, could be anything. Like I was saying a minute ago, you could plug in fractions, you could plug in decimals, you can put in partial amounts, like sometimes there's word problems, and how many pounds of, let's say you go to the candy store, one of those the candy stores where you dig out of the bin. Well, do you have to get exactly 1 pound? No. You can get a half of a pound or 0.1 of a pound, right? So that would be continuous. Discrete is when you have separate points that are not connected. And in that case was where, like, if I took the line off and I only had the points. In that case, the domain can only be integers. It's usually integers. There could be other qualifications, but usually it's integers. And that would be something like I was saying with the candy store, like, can you buy half a pound? Yes, that would be continuous. If you can't, if you have like 1 candy bar at a time or 1 jelly bean at a time, that would be discrete. You would not connect those because you can't do fractions. Okay, so the ones that you can do a fraction of would go here. If you're counting buses, you can't take half a bus, so it would be discrete. Okay, let's turn the page.